Say what? What?
Down because it comes up on your video, doesn't it?
What does?
The other class being loud.
Yeah.
I don't. Does it?
Yeah, we can hear it.
I don't think it's too bad.
Yeah.
Okay. So So we're starting with these are all the things that the examples are about. We covered the first one, 2 days ago, whenever that was, Wednesday, and that was the square root of 32 is the same as the square root of 16 times the square root of 2, right? Those kind of things. Okay, then there's the examples called multiplying radicals. And we just have to remember certain rules about multiplying radicals. In the example, they did this one. So this is example 2, all right, in the book. So I'm just going to use their thing. So it's the square root of 6 times the square root of 6. Now when you multiply radicals, as we remember with the product property, you can put them under the same radical sign, right? So that could be the square root of 6 times 6, which is the same thing as the square root of 36, which is 6, right? Now that's interesting. The answer is this. So would that always work? The square root of 18 times the square root of 18, can we say that's 18? Yes, we can. Right? Because really, I don't even have to multiply it out. I could even think of it like this. This is 18 squared, right?
Is a square? Yes, a square.
But what does a square root do to a square?
Annihilate.
They annihilate each other, right? They annihilate each other. They just totally destroy each other. Look at that.
No, don't kill
So
them
it
too.
equals 18. That's awesome. So what about this though? What if I had the square root of x minus 7 times the square root of x minus 7?
That equals x minus.
It equals x minus 7, right? Right? Because otherwise, I mean, it would be x minus 7 parentheses squared. Take the square root of that. The squares and square root cancel out, so you have x minus 7. So it's pretty straightforward, right? Whenever you have the same number under the two square root signs and they're being multiplied, immediately they come out as that number, right? So that's a great thing to remember because you're going to see those a lot, and it's going to be really helpful, especially eventually as we move down to number 6. We're going to see multiplying with distributive property, with radicals, and you're going to see square root of 2 times parentheses something, and it's got a square root of 2 somewhere, and that comes out as a 2 immediately. You don't have to worry about doing all this extra stuff. Immediately, it's just you know what it is. All right. So that's multiplying radicals. Actually, now let's do a little more complicated ones. Here's an example in the book. The square root of 3x times 4 times the square root of x. Okay? Right? So when you do this, what is the number in front of this one?
1.
A 1. There's a hidden 1 there, right? So it's just going to the 4 is going to stay there on the outside, and then I can multiply the things underneath the square root sign, right? So I can add them. Put them together. 3x squared. Am I right?
Yes.
All right. So that is the same as 4 times the square root of 3 times the square root of x squared, right?
Yes.
You with me?
4x.
Because that's okay. The square root of 3x squared is the same as the square root of 3 times the square root of x squared. But x squared of x squared, remember, is that x. That comes out as an x, right? So we've now got 4x and then the square root of 3. Right? Does that make sense?
Yep.
Now, when you write that, don't write it like this. Do not do this, right? No. Right? Don't do this. 4 square root of 3x. Don't do that. Because what it'll end up looking like is you'll draw your square root sign a little bit too long. It's going to look like the square root of 3x. You don't do that. So you always got to put the square root sign at the very end of your term. Okay?
Or next.
All right, so that's that one. How about this one? Square root of, this is our last one on this example. 7xy squared times 3 the square root of x. Okay.
That's a 7, right?
7. That's a 7 right there. Yes. So it's the square root of 7xy squared times 3 times the square root of x.
So we can take a y out, right?
So you can immediately, yeah. Now what I've been doing up here is showing you exactly what I'm doing, right? But technically, I can shortcut it a little bit, right?
Take out x.
I don't have to say the square root of 7 times the square root of x times the square root of y squared. I can just start thinking it in my brain, right? And I say, well, is there a square root of 7? No. Is there a square root of x?
No.
But is there a square root of y squared?
Yes.
Immediately the y squared comes out as a y, right? Immediately that's going to come out as a y, right? So I just got rid of my y squared there, right? It came out as a y.
Just free.
Now, what else can I notice? I have the square root of 7x times the square root of x.
You can combine x.
What is the square root of x times the square root of x?
X.
X. So I just got rid of my x's. I got rid of my x's. So I've also got an x out here. And then I still have a 3 on the outside.
3xy.
And I have a square root of 7 on the inside. So my answer is 3xy square root of 7. Did you follow that?
What? Yeah.
I did that the shortcut method, but where I just started looking at things. But I could have done it the long cut method too. It might have been easier. If I'd done it the long cut method, let's try that one.
Not a long cut, it's like a long track.
Yeah, it's not really a cut if you.
3x, whoops, sorry, what am I doing? Square, what is it again? Square root of 7x
7x y
y
squared.
squared times 3 square root of x. So I could do it like square root of 7 times the square root of x times the square root of y squared times the square root of x times 3. I'll put my 3 in the front. Okay? So look, these two multiplied together just become an x. So now I have a 3x. This becomes a y, so I have a 3y square root of 7. Maybe that's easier. Right?
Or you can just be like, how many x's do I have altogether, and how many y's do I have altogether?
Yeah. Yeah. And a square root will half the exponent, right? So, all right, so that's that. So we have finished this one, we have finished this one. Now we've got to talk about the quotient property. Can I erase this?
Yeah.
Someone say no?
Good job.
It's a very, very soft no. Whoever's saying no. So you know, feel free to waste like.
No.
Can I erase it now?
No.
No! Of course.
All right, I'm going to. Is that okay?
No.
Who's saying no?
Yes, we are.
All right, well, copy your next door neighbor's paper, okay?
I don't have a neighbor.
That's bad, Gary.
But be sure to put
Encouraging cheating.
but be sure to put a footnote at the bottom.
So that's what we're supposed to do on our next test, too, right?
Bibliography, right? Bibliography.
So
Okay.
at the bottom of our tests, we're going to bibliography.
Okay, in the book, example 3. Now we're going to example 3.
This makes no sense. No, I'm already like, ugh.
Example 3 is the quotient property, right here, right? 3, quotient property, example 3. So example 3. Sometimes you get something like this. Well, first of all, let me give you the actual rule. The square root of A. Are you taking notes, Liam?
Yes, I am.
Okay. The square root of A over B.
Equals the square root of a over the square root of b.
Yes. So you just like with the multiplicative approach, you can separate these as well, right? So because of that, you can take a problem that sometimes you can take a problem and simplify it very quickly. So for example, in this example we had square root of 13 over 100. So if I use this property here, the quotient property, I could then say that equals the square root of 13 over the square root of 100.
Oh.
Ah, but what's the square root of 100?
10.
10. So my answer is the square root of 13 over 10. Make sense?
That's like the final answer.
So,
Wait,
Nothing
but
else
shouldn't
I
we
can do.
get a calculator and find the square root of 13?
No. You could if you had to, but I'm not.
unless they tell you to
Do that whole
Only
property
if they
thing.
tell you to, or only if you need to know, like, how many apples fell from the tree, right? Then,
The
yeah,
square
I don't know what
root
the
of
But if
square
you're
root of
just supposed
13
to
over
solve
10
it, then
apples
you
is,
just
right?
leave that.
I'd love to know what that is, right? So, yeah, but for most of this, you don't have to
13
go
over
further.
10 is apples.
I'm not liking that marker. Okay,
Perfectly like.
so now one other thing. There is a rule, Nathan. There's a rule that says, do you remember this rule that says you can never leave your final answer with a radical sign in the
That's
denominator?
rationalizing the denominator.
This
right?
does this right here have a radical sign in the denominator?
Yes.
It technically does because that's the same as this, right? So if they gave you that and they said simplify, you have to get rid of that
So you would
that
find
square root of 100. And by just doing this process, we did. We got rid of it. That won't always work, but hopefully it will.
it. Does it work?
Doesn't always work. Well, there's another way. There's another way called rationalizing the denominator, which we're going to talk about soon. But I'm going to do just a couple more problems, or one more example. What if you had the square root? The square root of 7 over x squared. Again, same thing. Square root of 7 over the square root of x squared. That's the square root of 7. Whoops.
Over x.
Square root of 7 over x. Right? Pretty straightforward, right? Nothing hard there.
That's really
It's very difficult, Gary.
pretty complicated.
Very complicated.
I mean, square root of
Okay.
x squared.
So, but sometimes you will have a situation where this doesn't get rid of the square
Square root
root.
of 7 over the square root of 6.
Yeah, exactly. That would be an example. So we could do that one if you want. So
Then you could multiply it by square root of 6 over the
The
square
square root of 13 over the square root of
Square root of 700.
So let's do example 4. Okay? So example 4, we're talking about rationalizing the denominator. Again, you can't have a square root sign in the denominator, right? I mean, you can in the process, if you're in process. But when you finally get your final answer, you've got to get rid of it. And again, it's because of a long time ago not having calculators. And I don't want to go into it because I don't have enough time. But that's kind of why they came up with these kind of rules. They don't want to be dividing by a number, an irrational number, a number that never ends, right? The square root of 2, it never ends. It's an irrational number. It goes on forever.
divide by it.
Just like pop.
And to divide by a number that never ends, it's kind of a mess. You know what I mean? Especially if you don't have a calculator, right? So it would be so much easier to divide by just like 2, right? Than divide by 1.2, 7, 3, 4, 5, 6, 8, 9, 10, 0, 0, 1, 2.
Oh, that's
9,
so
10,
easy.
right? It'd be much easier. So that's why. But so with, okay, so example 4. So let's say I gave you 5 over the square root of 7. And we don't want that square root of 7 to be down there. And I can't take it. There's no
Make it a
easy.
negative. Make it a negative to bring it up, right? Or make the 5 a negative.
No, good thought. But what you do is you multiply it times 1, and it gets rid of it,
Multiply it by the square root of 7 over the square root of 7.
which is
1.
1, right? So if I multiplied this times 1, wouldn't you agree with me I'd have 5 over the square root of 7? So I didn't change its value. But I could multiply it times a really weird 1. The square root of 7 over the square root of 7. Do you agree with me that's 1? Okay, so that's going to change the way this looks. It's not going to change its value. Okay? So now, what do we know about the denominator? Square root of 7 times square root of 7 is 7. Immediately you know that. And then 5 times the square root of 7. That's what you put up here. So that's your answer. That's easy, right? Pretty easy. So another example, like Clayton said, the square root of 7 over the square root of 6. Okay, so what would I multiply it by?
The square root of 7 over the square root of
Square root of 6.
Square root of
7. Wait.
6.
Square root of 7 over the square root of 7. And then
the square root of 6 over the square root of 6.
If square root of 7 doesn't address the denominator. It's
Oh,
only
so
the
6.
denominator is the
6.
problem. So it's the square root of 6 over the square root of 6. So that equals 6 in the denominator. And then it equals the square root of 42, right?
What? Whoa, what? Oh, so you're actually
6 times 7 is 42, square root of 42.
Okay, so you're
Right?
actually multiplying the top.
Yes. Remember, you can, as long as they're both underneath the square root sign, you can multiply them. Right? Remember that? Okay. So then, where am I? I'm number 4. Okay. So what if I gave you this? The square root of, so that was our first one. That's A. And here's B. What if I gave you this one? The square root of 2 over the square root of 3 B. That's a B.
You just multiply by the
I'm
square
gonna
root of 2,
write.
right?
I'm gonna write in capital so it's obvious. 3B. What would I multiply by?
The square root of 2.
Square root of 3.
The problem is the denominator. It's not the numerator. It's only the denominator.
Oh.
You see what I'm saying? The rule is the denominator. It's fine to have square roots in the numerator. Not fine to have them in the denominator. So it's the denominator I want to get rid of. So I'm going to multiply it times the square root of 3b over the square root of 3b.
So would the answer be the square root of 6b over 3?
3.
3b?
We have 3b in the denominator.
3B.
And this would be 6 square root of 6b, exactly. Okay? Does that make sense? All right, now I'm going to throw one more example, and just because they didn't put it on here, but I'm going to do it. C. What's my example? What am I thinking? So what if I gave you this? What if I said 5 over the square root of 12? What would you do, Sal?
To simplify it,
Uh-huh.
take out the 4 out of 12. You could do that, or you could just multiply it by the square root of 12.
So there's two approaches, right? Sal saw them both immediately. You could multiply everything by 12, the square root of 12 over the square root of 12. But the problem is you're going to have to simplify it. You know, you're going to have to simplify it. Because what's the square root of 12? Remember how to simplify that?
That's 2 square root of 3.
Yeah, it's the square root of 4 times the square root of 3, right? Which means we have 5 over 2 square root of 3. You with me? So it's easier to simplify it right away,
And then
in my opinion.
divide it by
And then, what is the problem?
the square root of 3.
The square root of 3. Is the 2 a problem?
No.
No, the 2 is not a problem. You can have a 2 in the denominator. It's just the square root of 3. So now you just multiply top and bottom times the square root of 3. Right? So then that gives you, is that showing up on this thing? Yes. Okay, so that gives you 5 square root of 3 over 2 times 3, right? 2 times 3. So that equals 5 square root of 3 over 6. That's my answer. Does that make sense? Did I lose you guys on that one? Okay. Okay. I'm running out of time. So,
You have 1 minute.
adding and subtracting radicals.
It ends at 12:30.
I need more time.
Ask for 5 minutes.
But it's lunch.
No, it's lunch, Sabrina.
I know I can't do
Didn't
that
have
to you.
breakfast.
All right. So what I'm going to do? So I'm going to do one really quick example. Okay. Okay. Square root. If I did 2 square root of 12 plus 4 square root of 27, you cannot. Okay, so wait.
They have
Just,
to be like terms.
you can, yeah, they have to be like terms. They have to be, in order to add the coefficients, the 2 and the 4 together, these have to be exactly the same numbers, right? But they're not. So we have to try to simplify them first. So we've got the 2, and then square root of 12 is the same as the square root of 4 times the square root of 3, right? Plus 4
But you could
times
put
the
those under
square
the
root
same-
of 9 times the square root of 3, right?
But couldn't you put those under the same,
No. You cannot add 12 and 27.
no, I mean like 9 times the square root of 3. Couldn't that be under
You could
one
keep it
radical?
under the same one if you want. That's fine. I'm just showing you exactly what I'm doing, right? So,
Square root of 3
That comes out as a 2, right? 2 times the 2, not plus the 2. 2 times the 2, right? Square root of 4 is 2.
Yeah.
That says 2 times the square root of 4. So it's 2 times 2, which is 4, times the square root of 3, plus this 3 times 4, which is 12, square root of 3. So now I have like terms, right? I have like terms. So now I can add them. 4 plus 12 is 16. 16 square root of 3. That's my answer. All right? So that is adding and subtracting radicals. The last one is multiplying. It could be just like
Are we also gonna do word problems?
distributive. No. That could be, I mean, maybe eventually, but not for this section. But for, like if you have distributive property, if I had the square root of 2 times 3 minus the square root of 2,
Are these gonna be on the homework?
right? You would just multiply them out and you would get them. It's pretty easy. Read the example on that last one, on example 6. Read through that. Homework tonight,
No, homework for Monday.
homework for Monday.
Can you write it up on the board?
Yes. So homework for Monday. 70 and 72A, 70 A, B, and C. Okay. All right. So page 723 through 724. Numbers
1 and 2.
okay, 11 through 14, comma,
Comma, but
26 through 29,
Wait, 11 through 14 and then 26.
26 through 29, and then 34 through 39, and then the last one,
Oh no, Gary.
it's a lot, Gary.
Gary, I
Come
think
on.
that's enough.
Because we have so much to do
You have
when
a
it
lot
comes.
over the homework.
Yeah, like no, we don't.
this is not that much,
This
guys.
is the only homework we
Yeah,
have
they
pretty
do.
much.
We have this
We
and
had a
science.
And then for conceptual,
I have more time homework.
Oh, and we had Japanese.
Yeah.
for conceptual, I have 2 more problems for you. Number 70 and A, B, and C, and 72A.
Conceptual anymore.
Okay?
I was like, yes. I just love this picture. Don't you, Serena?
No, I hate that picture.
What picture? Oh God, that picture.
I could have gone, but I
Serena, give me a copy of what?
You guys, add 42 to this.
Okay.
Add 42. Add 42. Add 42. Liam, add 42. Also 42.
Oh my gosh. And, so Gary, is the video still on?
Yes.
Yes, so can you do this like every day so we can still have the
If you can remind me.
on the